Hi guys, we're Team 10, and I'm Josh Zoe.
Um,
This is
I'm
Ayush,
Ayush.
and this is Elliot. Now, I was asked to open, so just gonna start with a little demonstration. So, surprisingly, most of you guys have an iPhone. That's not surprising. But what is surprising is this is a perfect demonstration of both a capacitor and a battery. This is basically what we talked about this morning. So, it's a battery usually, but when you go to the photo and turn on flash, it becomes a capacitor. It discharges electrons almost instantaneously. So basically, batteries are the transfer of electrons in chemical reactions called redox reactions, and we use that to power devices. On the other hand, capacitors work on a different scale totally, using two different plates and charging one with electrons, and then as soon as the circuit opens, the electrons flow out. Now, you use both of these for completely different functions. Like, you wouldn't want an iPhone battery with a lifetime of like maybe at most 2 hours, and you wouldn't want an iPhone flash with like a 2-hour long flash, but only like minuscule power. But what if you want something somewhere in the middle? What if you want something like a bus battery that lasts from one stop to the other and you can charge it at every single stop? Something that charges fast, a little slower than a capacitor, but faster than a battery, and has almost as much almost as much electrical density as a battery. And that's where the supercapacitor comes in. I'll turn it over to Elliot.
All right. Thank you, Josh, for that. So now we're gonna analyze this picture, this beautiful picture. How do I turn this on? All right. Okay. There we go. So this picture actually takes place in the hood, which, if you don't know, is basically the ghetto, and a lot of stuff goes on in the hood. So there's look here. There's people standing between the street and the wall, and people represent electrons. And then, since they're doing sketchy stuff, the cop comes over, and then the people scatter. They go back to the wall, and that kind of represents a capacitor because basically the police, they charge when they come. They make the people, the electrons, go to the other plate. It's kind of how a capacitor works. And then if you go down, there's a bigger hood, and this one has two buildings instead of the cop car and the wall. And this one basically has a bunch of people standing there, kind of like the dodgeballs in the other picture. And when the cop car comes, the people scatter, and they go to both sides in this case because it's a super capacitor. And as Josh mentioned, although this one may have more power than the supercapacitor, this one does compromise some of that power for a longer lasting energy source. And now, Ayush.
So I'm gonna tell you what's like good about the picture and what I thought they could have done better. So I like the way that they show how when the cop car comes, which could be signifying the electrolyte, it comes and disperses each ion to the sides like a capacitor. But the only thing is they never showed the ions coming back and shooting, discharging it. And in the top picture, it looks like there's only one plate here, and the problem is with capacitors, there's no electrolyte, so the cop car doesn't make as much sense. Any questions?
Okay, so what do you guys think the cop car is?
Electrolyte.
I think that's not it.
The cop car is like a signal almost.
Okay, so what in your experiment is the cop car?
It would be the moment that we press the button twice.
And what happened when you pressed the button?
It opened the circuit, and so the electrons started flowing past.
So what is the cop car doing here?
It's essentially sending a signal to the street, the side of the street, which makes the electrons go to the other side, the other plate.
But in people, you send a signal and then they can decide to do something because they have a brain and they can take information and act. But chemical systems have no brain, and so a signal is not necessarily enough to force something to happen.
But like basically the reason why they made this take place in the hood was because like statistically speaking, a lot of crime happens in the hood, and when a police car usually shows up, the general instinct is to run away.
This is all good. That's fine. But in your experiment, so the cop car is not a signal. The cop car is the thing that's making the electrons move. What's making the electrons move?
So in a capacitor, a supercapacitor, each side is charged differently. So one side will be charged positively, and the other side will be charged negatively. So
This charging thing you speak of, how do you do it?
So the problem is the police car actually acts in this picture as a positive force, like forcing them to move. But
It's a
actually,
force.
yeah.
What was your force in
there
your
was
experiment?
no force because
There,
actually
of course
in
there was a force. Nothing happens without a force.
in the capacitor, the force came when we were charging the plates, when we were pushing the electrons to one side, pushing the ions to one side or another, and then when you let go, they all ricochet and then disperse themselves again.
Okay, yes, exactly. That was excellent. So, in this case, what is the thing that is forcing the in your experiment? What is the thing that forced all the ions to one side?
The potential difference in the current in the
voltage. Okay, so the cop car is
voltage.
yes.
All right.
Okay, so now my next question is: the people are not the same things in the two experiments. How are the people different?
So a capacitor and a supercapacitor are kind of similar in concept, but they work pretty differently. So in the first one, people kind of represent the electrons, whereas in the second one, they represent ions.
In the first one, also, all the electrons are the same charge, but in the bottom picture, the plates are one charge, but in the bottom picture, there's different charges. Each plate is a mixture of different charges.
So, right, electrons only come in one flavor. So you can only have electrons or lack of electrons, but ions you can have positive and negative ions. So in this case, you'd say people are all charged things, even though there are electrons in one case and ions in another case. Okay, good job.
Thank you.
Now other people have to ask them, no, you can't clap yet. Somebody else has to ask a question.
Oh, nice.
Well, see, that's where the nanoscience comes in, because in a regular capacitor, you have one, like there's. Well, I would say that was because in a regular capacitor, only one side is doing the action, while in a supercapacitor, both sides are either gaining positively charged electrons, positively charged particles, or negatively charged particles.
Also, I think it's to show that in the first one, in the capacitor, each plate is different, but in the supercapacitor, they're similar.
They don't really have any specific name, that I know of. Oh, they do? What's the term? Positive plate.
No, because usually a capacitor is like two plates of metal or And Eric, you had a question too, right? Well, you would increase the surface area because that would allow for the storage of more electrons.
And in the picture, what would that be?
A longer wall or more, or
More
like
buildings.
higher apartments.
Or more buildings.
Higher apartments is the way, because the whole point is in a parallel plate capacitor, you can't really increase the density per unit area, but in the supercapacitor you can. So higher apartment buildings would be the perfect way.
Thank you.